Students, we are going to see today concept related to mensuration. Now when we say mensuration, mensuration has many geometrical figures. We are going to talk about some of them today. What we are going to see today is a rectangular parallelepiped, a cube and a right circular cylinder. Now all the figures have some amount of formulas. We are going to understand all the formulas regarding to this particular figures, and I from my side shall see to it that I make you understand how the formulas have been derived. The very first to go with is a rectangular parallelepiped. The other name for rectangular parallelepiped is cuboid. Now if you happen to look at a rectangular parallelepiped, it's a complete box-like structure with length, breadth and height as the parameters. Now if you happen to look at it, it's all the faces of rectangular parallelepiped happens to be a rectangle. Let's see, if I pile n number of books one above the other, the composite structure what I get is nothing but a rectangular parallelepiped with this as your length, this as your breadth and this as your height. Now this is nothing but a rectangular parallelepiped. Before we proceed further, let's see how many faces does a rectangular parallelepiped has. When I lift this particular pile of book, you can see it very clearly. Now there are 6 faces in total. If you happen to look at it, face number 1, which is the lower one, lower base I should say. Face number 2 is the above top. Face number 3, face number 4, which is exactly behind. Face number 5 and face number 6. So in totality there are 6 faces. Now having said that there are 6 faces, let's see how many horizontal and how many vertical. If I consider the base part and the top part, these are nothing but the 2 horizontal faces which are rectangle. And if we count this one, this one, this one and this one, these 4 are regarded as vertical faces. So how many horizontal students we have? We have 2 horizontal, and how many vertical do we have? We have 2 vertical faces. Now we start off with the formulas. The very first one is nothing but the area of base. Now if you just look at the base portion happens to be a rectangle, length into breadth. At the same time, if you happen to look at the top also, the top is also length into breadth. So one can say the area of base, is equals to the area of top portion, which is nothing but length into breadth. Having said that, when I've said area of base is equals to area of top, which is nothing but length into breadth, we have said about the horizontal face. Once again, if you want, you can have a look at it over here. This is nothing but the base, this is nothing but the top portion. The base portion is length into breadth, so as the top portion is also length into breadth. With this, we say that the 2 horizontal faces have area length into breadth. Having said that, now we have to account for the vertical faces, the 4 vertical faces. So now the second point is to get the formula for area of vertical faces. Area of vertical faces. Now students, I shall give you today a general formula for area of vertical face. Area of vertical face is nothing but perimeter. Area of vertical face is nothing but perimeter into height. Now as I stated earlier that every single face of a rectangular parallelepiped is nothing but a rectangle. And now when I have said the general formula is perimeter into height for area of vertical face, let me first write down the formula. The formula is twice L plus B into height. That is h. One can say it's twice L plus B into height, which is h. Let's see how this formula has come into existence. We try to derive from our side. Now what I want is that students need to visualize some amount of concept which I want that they can think. They should have a high visualization capability. This is nothing but a rectangle which I have drawn. This is nothing but a rectangle, a small rectangle which I have drawn. Now with this rectangle, if I lift this book over here, are you in a position to see a vertical face? Indeed no, you are not in a position to see any vertical face. Why? Because the thickness over here is nothing but a very, very negligible thickness it has. So you are not in a position to see a particular face. So imagine it's a wire, it's a hollow wire. and you are not being able to see the face as such. Now what I would like to do is, I would like to pile a wire above the other, and I would like to pile n number of wires, and the structure will be, if I say this is nothing but one wire, this is nothing but the second wire, this is nothing but the third wire, and so on. I have kept n number of wires. What have I done? I have increased the height. The moment I increase the height, the faces appears. The faces which were not there initially, now the faces come into existence and one can see the faces. Earlier the faces weren't there, but now when I increase the height, the faces are there. Thus we say it is perimeter, because when we say from here to here, sum up all the sides, the answer is perimeter. Perimeter into height. When I just increase the height, I do get the faces. Thus it is perimeter into height. Since every face is a rectangle, perimeter of rectangle is given by twice length into breadth into height. Perimeter of rectangle is given by twice length into breadth, twice length plus breadth into height. I'm sorry, it is twice length plus breadth into height. Thus, the area of vertical faces, turns out to be as twice L plus B into H, that is height. Having said that, we need to focus on what is the total surface area. What is the total surface area? Now, when I say total surface area, it should sum up all the 6 faces. Let's see once again over here. When I lift this particular book, you must be in a position to see it very much distinctly and clearly. As we understood now, there are 6 faces, 2 being horizontal and 4 being vertical. Let's calculate. Total means everything. Let's see. Students, right now we studied that if this is length into breadth, so as length into breadth. So how many length into breadth we have? 2 length into breadth. If I count this face, then this is breadth into height. If this happens to be, if the area of this face happens to be breadth into height, so as will go with this face as well. So how many breadth into height, students, we have? We have 2 times breadth into height. Having said that, let's see the front face. The front face has area length into height. The front face has area length into height. Same goes for the back face as well. So how many length into height we have? We have 2 length into height. Let's sum up all of them. So how many length into breadth we had? We had 2 length into breadth. How many length into height we had? We had 2 length into height. And how many breadth into height we had? We had 2 breadth into height. Having said that, 2 being common, LB plus BH, I'm taking this first, plus LH. So what is total surface area? Total surface area for a rectangular parallelepiped is twice length into breadth, LB, plus breadth into height, BH, plus length into height, LH. So we say in this particular way, twice LB plus BH plus LH. Having said that, we have accounted for the area for all the 6 faces. Let's go for volume. Now, when we stated for vertical face, I give you a general formula, perimeter into height. And with that particular general formula, we went for derivation of area of vertical faces. On a parallel line is what I would like to go for volume. And volume's general formula is area of base into height. Now when I say area of base into height, what is area of base of a rectangle? Area of base of a rectangle is length into breadth. So area of base is length into breadth into height. Into height is nothing but h. Thus the volume turns out to be length into breadth into height. The volume turns out to be as length into breadth into height. Volume's general formula is nothing but area of base. Over here we have seen what is base area. The base area is nothing but length into breadth into height. The answer is length into breadth into height. Now with this we complete our rectangular parallelepiped. Some basic formulas for rectangular parallelepiped. Once again I shall refresh. Its area of base is equals to area of top, which is length into breadth. These are 2 horizontal faces we are talking about. Area of vertical faces, there are 4 vertical faces, students. So area of vertical faces, the general formula happens to be perimeter into height. So area of vertical faces being twice L plus B into H. As I stated earlier, that every face is a rectangle, thus the perimeter is twice L plus B into height. The total surface area, as we earlier said, it is twice LB plus twice BH plus twice LH, 2 being common, LB plus BH plus LH. And finally, the volume is area of base into height. Area of base over here turns out to be as length into breadth into height. So the answer is length into breadth into height. Now we come across, after finishing parallelepiped, we come across cube. What lies the difference between a rectangular parallelepiped and a cube? The difference between a rectangular parallelepiped and a cube is nothing but, if you happen to focus on the diagram, here it was length, here it was breadth, and here it was height, h. All the three dimensions, length, breadth and height, were different. Now if you happen to focus on the diagram of cube, you shall find out is, I have written over here length, I have written over here length, and I have written over here length. What do I mean by saying this? The length, the breadth and the height in a cube happens to be the same. Whereby which, on the other side, the length, breadth and height were different for rectangular parallelepiped. The only difference between rectangular parallelepiped and cube is that the length, breadth and the height have same dimensions. Thus, I have written length also length, breadth also length, and height also length. When the structure is length, length and length, immediately one can visualize that in a rectangular parallelepiped, every single face was a rectangle. Here, every single face is going to be square because the base is also length, the length is also length, the base is also length, and the height is also length. So every single face, if you see, is going to be a square. Absolutely on a parallel line, how many faces we studied in a rectangular parallelepiped? There are 6 faces in total. In cube also, there are 6 faces in total. How many horizontal we studied over here? There were 2 horizontal. Over here also, there are 2 horizontal, the top and the bottom. How many vertical over here we studied? 4. There are 4 vertical faces on the sides of that particular horizontal face. So in totality, how many faces we have? In cube, there are 6. And each face happens to be a square. Absolutely on a parallel line, let's work out the formula for the same. Area of base. Now I shall go absolutely on a parallel line how I worked out for area of parallelepiped or a cuboid. We shall work out for cube as well. The first one is area of base. I shall say area of base, and if you happen to look at the figure, whatsoever is the base area, so shall for the top as well. Area of base is equals to area of top is equals to, now over here you can say it is length into breadth. As I stated over here, it is length into breadth, but over here it's going to be length into length. So one can say it is L into L, which is L square. L into L is equals to L square. Area of base is equals to area of top, which is L square. Second one is area of vertical faces. Area of vertical face. Now area of vertical face, once again I shall say it is perimeter into height. It is perimeter into height. Now as we studied over here in rectangle, or rather in